This is problem number 80 from page 337, and the directions are to find all complex zeros, and I usually call those roots. So basically find all the roots, whether they're real or non-real, find them all, give exact values, not decimal approximations, and list multiple zeros as necessary. Okay, so here's our function f of x, and even though the directions don't say to, I'm going to go ahead and start by finding the APRR list, the list of all possible rational roots, because that will help me in finding the roots. So look at the constant 12 and find the factors of the constant. Those are the potential numerators. So all the factors of 12, plus or minus 1, 2, 3, 4, 6, and 12. And then look at the leading coefficient, which, in this case is 1. All the factors of 1 will be all the potential denominators, so just plus or minus 1. And then when you put together all those numerators with all those denominators, you get your APRR list. All possible rational roots is what APRR means. So everything over 1 is just going to be plus or minus 1, 2, 3, 4, 6, and 12. Okay, we know that if there are any rational roots, they have to come from that list. Now to go ahead and find the roots, I'm going to make my synthetic division chart. So I'm going to put 0 in the middle, give myself plenty of space above and below, and put the coefficients from the problem, 1, -1, -8, and 12. 12 is going to be the remainder, so make a line to separate your remainder column. And then we're going to start by dividing by 1. So write a 1, bring up the first number, multiply by the number in the box. This is your box over here. 1 times 1 plus the next number in the 0 row. Remember, always go back to the 0 row, and it's a good idea to highlight it or do something to make your 0 row stand out so that you always remember to go back to it. Okay, 1 times the number in the box plus the next number in the 0 row. 0 times the number in the box plus the next number in the 0 row. -8 times the number in the box plus the next number in the 0 row. Let's go again. 2. Bring up the 1. 1 times the number in the box times the next number in the 0 row. So 1 times 2 plus the next number in the 0 row. So 1 times 2 plus -1. 1 times 2 plus the next number in the 0 row. So 2 plus -8. -6 times 2 plus the next number in the 0 row. -6 times 2 is -12, plus 12 is 0. Okay, good news, we have a root. So we have a root at x equals 2. Now how many roots does this problem have? Because it's cubic, it has 3. We have 1 root, there are only 2 left, and remember that right here, these numbers are the remaining quadratic. So take those numbers, put them into a quadratic, x squared, 1x squared, plus 1x minus 6, and then set that equal to 0, and you can find the remaining 2 roots. If this is factorable, great. If not, use the quadratic formula. Just so happens that this one is factorable. So set each factor equal to 0 and solve each one, and we get x equals -3, and we get x equals 2. Okay, notice that I didn't have to make very many rows in my chart this time. That was nice, but you never know when you start how many rows you're going to need, so it is valuable to make the chart and to go in order and be organized, even if it turns out you don't need it very much. So finally, we're going to write our roots, and it says that they should be exact, and it says that we should list multiple zeros as necessary. So we did get multiple roots of 2, so I'm just going to list x equals 2 and list 2 again and list -3. I want to show that I did find 1, 2, 3 roots, and so that's why I list the 2 twice. I want to make sure that we've covered them all. Okay, that is problem number 81.